Okay, so let's get started. I hope that you can hear me loud and clear. I'm pretty excited for this webinar. I worked pretty hard to make it happen. And before I'm starting, I just want to explain why. So I'm using systems thinking for a long time. It helps me tremendously in my career. It helped me to resolve very complex problems, to manage to achieve stuff that people before me tried but didn't. And I truly believe that system thinking is something that is really needed in today's world, especially as the world becomes more complex and more uncertain. Now, what I find out that there are hardly any materials on the web that explain how to do system thinking in practical way. So there is a lot of materials that explain or walk you through how you should do system thinking from theoretical point of view, but system thinking comes with a very robust tool set that can help you to do amazing stuff. And I think that we have a problem with the broadcast. Okay, so I think that we're up and running. So again, sorry for the technical issues. What I find out that there is very few materials on the web that help you to learn how to use or what are the available tools that system thinking enable you to provide. And this is our very tangible tools that exist out there. So that's the reason why I did the webinar. I worked pretty extensively in the last 2 weeks to collect all the notes that I had, all the experience that I gather in order to expose you to the more practical portion of systems thinking. So I'll start with why system thinking, because I think that's obviously the first question that people will ask. So I think that we all aware of around 15 different problems that exist in our organization and in the last 10 years, and they never go away. There are kind of reoccurring problems, whether it's a customer satisfaction or lingering project or the difficulties to recruit and retain people. All of those are very common problems that we see in organization all the time. And the question is why? Why, with all the tools that we have, with all the knowledge that we have, we are struggling with resolving those recurring problems? And what I find out, and what I will try to explain in a second, is that the reason that we have a problem is simply because we are using the wrong tools to resolve problems that those tools are not meant to resolve. And the best way to explain it is to start with 3 types of problems that we are facing each and every day. So the first one is a simple problem. And if I ask you to tell me what is the highest peak of Fuji mountain that you can see on the top, probably it will be extremely easy for you to say what it is, because this is a very simple problem. On the other hand, if I'll ask you to find out what is the highest peak of the Rocky Mountains, that would take time and effort to calculate, because there are too many options, and it needs time. We need time in order to consume all the options and find out what is the result, which actually took humanity quite a lot of time to find the highest peak. This is a complicated problem. Because we have too many options, it makes the problem more complicated. Now, if we take the Rocky Mountains and we assume that severe volcano activity start to be there, and this severe volcano activity actually caused the peak of the mountains to change all the time because lava going in and out. Now we are dealing with a complex problem. We are dealing with a complex problem because it's impossible to predict which mountain will have the highest peak due to the unexpected behavior of the volcano activity. those are complex problems. And what happening is that all of the problems that are reoccurring, or most of the problems that we are carrying, they are complex problems. We, as management, have wonderful tool to deal with simple and complicated problems. But when it comes to complex problems, we are not using the right tool to resolve complex problems. We are still using the tools that meant to use for complicated problems. And system thinking is probably the best set of tools that exist right now that will help you to deal with complex problems. And this is the reason why I believe that system thinking is something that we need. Now, system thinking is not so simple to implement for one reason. It is a major shift, or it's a shift in thinking and in mental models that we have in our head. So first and foremost, system thinking is a practical result of complex system. And complex system is a science that explains how systems like organization are operating in complex environment and operating their own complexity. So that's the origin of a system thinking. And what system thinking doing is changing three main elements in our current thinking. So the first change is a change from a linear to a non-linear thinking. When we think linearly, we have A and we have B, and we know that A impacts B. As we are putting more effort on A, it's going to have more impact on B. Non-linear thinking, A impact B, but B impact A. And we might put very small effort in A, but it will have tremendous impact on B, or the other way around. So this is the first thinking, change in thinking that system thinking is doing. The second one is shying away from reductionism. So reductionism is what we are doing in analysis. We are taking a problem, we are breaking it to smaller and smaller parts. For simplicity, we are trying to resolve the small part and then combine it all together, and voila, we have a solution, or we don't have a solution. But from system thinking perspective, we shouldn't do that. Instead of breaking stuff apart, we should do the opposite. We should understand how the whole is working together and try to find issues and challenges within the whole. And last but not least, as I mentioned in the previous slide, determinism is not the case. So you can't predict what is going to be in the future, and your ability to control what's going to be in the future is very limited. We can see it now very clearly. And when you're doing system thinking, you have to take it in account. If I'm putting everything together, system thinking is a way to resolve problem by understanding how all the parts that creating something are interlinked and connected one to each other. And that's everything in a nutshell. When we should use system thinking. So system thinking comes with a cost like everything else. So the first thing that you want to make sure that you're using it for problems that are complex. If you're using it for problems that are complicated or simple, you're simply wasting time and effort, and you're using, again, the wrong tool to resolve a problem. The best way to know if a problem is complex is to look for reoccurring problems. Every problem that you see in your working environment that's coming again and again and again, those are most of the time complex problems, and you can start to address them with system thinking. And last but not least, that should be important problem for you to resolve. As you can see, system thinking doesn't come for free. You have to put time and effort into it, and you don't want to do it if it doesn't really matter. So two more slides that will deal a little bit on the concept of system thinking, and then we will going to dive into the practical portion of it. System thinking is extremely rely on something they call mental models, and mental models are context or beliefs or values that exist in our mind, and are shaping how we think and are shaping how we behave. And it's important because, as you can see in the ladder of inference, when we are resolving problems, the first thing that we are going to do is to select which data we are going to work on. And this selection is impacted by mental models. Then we are going to make interpretation, which also based on mental model. Based on the interpretation, we are going to draw a conclusion. And again, this is impacted by mental models. And by the conclusion, we are going to take actions and going back to available data to deal with another problem. But what's important is the circle on the other side. What you can see that the mental models are influence our decision, and their decision actually reinforce the mental model. And this is important for two reasons. The first reason is you have to understand when you're doing system thinking what are the mental models of people that involved in the domain that you are trying to address. And second, and more important, is that you have to be aware of your mental models. Because if your mental models will cause you to select the wrong data, or to make the wrong interpretation, or to draw to wrong conclusion, you're definitely not going to end up with the results that you should. You're going to end up with the results that you want. Now, in 10,000 view, system thinking has two main aspects. There are many concepts that exist, and we are going to discuss just the iceberg because I think it's important to understand the philosophy or thinking of system thinking. And there are tools that exist that will help us to take the ideas and turn them into practicality. So the first one is the iceberg model. And the iceberg model is pretty simple but profound and important to understand. It says that what we see are events. And when we see events, the only thing we can do is just to react. But events are actually governed by pattern. Certain pattern creates certain event. And patterns are set up by the structure that we defined. And the structure is a product of the mental models that we have in our brain. And if we want to change patterns, we need to try to anticipate what they are, and then we can start to be responsive instead of reactive. If we want to impact the patterns, we have to design the structure that we are using. And if we want to change the structure, we have to transform mental models. And this is probably the most hard part. So this is the concept part. In reality, there are three main elements that exist in the practical part of system thinking. There are models that are defined by visual language. There are graphs that help us to understand how elements in the system are operating. And there is a way to run simulation and validate models or see how models going to sort out how changes in the system or changes in the model are going to impact the future of your organization or the domain that you modeled. So let's take it one level down. There are three types of models that system thinking offer. Each one of them is providing different aspects. If you want, I think the best way to understand it is our body is a complex system. And if we want to understand it, we tend to scan it in different ways to see different elements of the body. So if we will scan the nervous system and the muscular system and the vascular system and other system, we will eventually have a 3D view of our body. We know how those subsystems connected to different organs, and that gives us ability to look at the whole and start to understand where there are issues or challenges within our body as a whole. And the same idea reflects to system thinking. The nervous system is going to be causal diagram that we're going to discuss. The muscular is going to be agent-based diagram, and the vascular is going to be stock and flow, and we are going to touch each one of those three in a high level and then see an example. So you're going to see diagrams throughout this model, and I just want to make sure that you're aware that there are free modeling tools that support system thinking, support the language, and you can use them for free. One is net logo, the other was insight maker. You'll see insight maker throughout the video or throughout the webinar. I'm using insight maker because it's much more easier and it doesn't require the developer to create a model. Most of the models can be done by regular people without any knowledge of programming at all, which I find much more easy to implement. So causal diagram are they're very simple diagrams. You see it in a second. And those diagrams are all about to understand how one element in the system impact another element in the system. We're using it to get high-level understanding of the system behavior. And we are usually using them in order to communicate between people that are doing system thinking and people who are not. They are easy to understand and are high enough in order to understand what's going on in the system. And on the other end, what's wrong or what are the opportunities in the system. So let me go through examples and explain you what are the main elements. So there are like three main elements in system in causal diagram. Pretty simple. The first one are variables. So variables are elements in the system, usually nouns, that are going to impact other elements in the system. And what you see here, it's a very simple example of causal diagrams. The bank balance is one variable. The earned interest is another variable. Variables are connected with lines. The starting point is the cause. The end is the effect. And as you can see, lines might have S or O or plus or minus. We'll we will use just plus and minus, the same thing S and O. And plus means that this variable, the bank balance, is actually increase the earned interest. And the plus here means that the earned interest is simply increasing the bank balance. And in a nutshell, this is all the idea of causal diagram. It just, you are getting more and more variables and more impacts between them, and it's growing over time to something that is larger or more complicated than the diagrams that you see here. Anyway, these two variables and the two lines that connect them cause a loop. And there are two types of loops, and they are important to understand. The first loop is reinforcing loop, and the earned interest and the bank balance is a positive reinforcing loop. It's always going to increase the system to highest and highest level. Reinforcing loop can be also negative. So if it will be minus here and minus here, then the entire system is going to go downhill instead of uphill. And this is two types of reinforcing loop. Loops can be also balancing, and the example under delay, it's a good example of balancing loop. So everyone has a certain degree of hunger, and when the degree of hunger is going up, we are going to be more hungry and we are going to take something to eat. When we are taking something to eat, then over time our degree of hunger going down, and since there is uneven numbers of positive and negative impacts on variables in the system, this is a balancing loop. Delays are a way to depict that the cause and the impact are not immediate. And it's extremely important because it's creating very hard to understand problems. For us as people, it's very hard to understand delays, and as the delays takes more time, it's harder for us to grasp it, to understand it, and to understand what are the consequences of it. And in this simple example, once I'm eating, it takes time up until I feel that I'm not hungry anymore. And that causes people to eat like crazy. And then in the good case scenario, you're going to have some problem in your stomach. The bad case scenario can be 10 times worse. But the delay is something that causes you to eat without understanding or thinking what would be the consequences. Very important, very prominent in systems, one of the main problems that you see in organization. So those are the three main elements of causal diagrams. The last thing that I want to discuss about causal diagrams is behavior over time. So each and every variable should have a small diagram that depicts historically how this variable is operating. And this historical data is actually help us to understand problems that exist or opportunities that exist within a causal diagram. Now, what we saw so far is a very simple causal diagram. Here you can see more real-life example of the claim problem in health insurance, which is more in detail and has more impact than a simple loop. Causal diagrams are very beneficial because causal diagram coming with a list of archetypes, and archetypes are actually combination of loops that, if they exist, it is an indication that we have a systematic problem, a non-systematic problem in the system, and those problem has names, and when we find this name, or we find this pattern or archetype within the system, we know that we have an issue. Archetypes also give us what is the solution. So it's not just that we know that there is a problem, we also have an instructions or ideas how we can go and resolve the problem. So while doing causal diagram, you are already getting a lot of benefit just by finding archetypes. You can find whatever your system has problem and doesn't have a problem. And I can testify that for all the models that I've done so far, I never was in a position that we didn't find at least one archetype that was applied, or we find out that it's applied to the system or the domain that we mapped. So it's extremely helpful. Now, this is causal diagram. They are giving you high-level view of a system. You can start to see delays, and you start to see balancing loops that or loops that are contradict one to each other and creating a problem in the system. You can see pretty clearly that here in this health insurance, if the doctors won't have any problem with putting claim error, then the system will generate revenue without any problem. But the problem is that they do have, and that start to create discrepancies, and those discrepancies actually have negative impact eventually on their bottom line. And we all know that there is a struggle with claims in health. The second diagram that we want to talk about are flows and stocks. And flows and stocks are actually, as we mentioned before, they are responsible for the vascular element in the system. So they will be very helpful to understand the flow. And they will understand the flow by mapping what are the inflows and what are the outflows that exist in variables in the system that hold data. And those variables that hold data are stocks, and flows are how the data flow between them. And this gives us lower level understanding of the system, and usually expose us to much more profound and smaller problem than the causal diagram give us high level. And instead of going through all of the name, let me show you an example and explain you how it's being done. So here on the side, you can see a very simple causal diagram. And there is a simple rule if you want to take a causal diagram and transform it into flow and stock. And it's pretty simple. The idea is you stop time and you think whatever element has some value or go to zero when you stop the time. So pray birth and pray birth are the same. What turned this pray birth from a variable here into a flow, and pray population from a variable here into a stock, is that if I stop time, pray birth will go to zero, but the pray population will stuck in a certain value. And that's one of the simple rule of thumb how to convert causal diagram into flow and stock. And as the name mentioned, flow and stocks are mapping the flow. A stock is like a sink. It has certain amount of information or materials that it maintains. the flows are or inflow or outflow. The inflow will add more element into the sink, and the outflow will remove element out of the sink. Both inflow and outflow might have a delays, and when we introduce a delay, it will change the behavior of the entire system. Every element will have a behavior over time. Every stock will have a behavior over time, so we can see and understand how it behaved over time. Variable here doesn't hold anything but values that can be constant or can be changed, and those values are impacting the flow in or the outflow on the other side. Graphical functions are important, and in this particular scenario, the graphical function depict visually what is the relationship or influence of prey on predator. So they are really important, and they are really valuable once you start to understand the problem in the system. Structural behavior, this is like behavior over time, but it takes an element in the system and it starts to understand how this element behave historically, and you can see here it's oscillating. So whatever I expand here goes here, and we took something that is more amorphic and we translated something that is more easier. Now the nice thing about stock and flow is that you can start to put data in, so you can define what is the basic value of those stocks, and you can define rules that will govern how much data will flow in or flow out. And once you're doing that, you can run this model for a particular period of time and simply see how the system behave over time. So you can see here the nice isolation between the predator and the prey, and you can see here the isolation in a different way. So there are different ways how to see it, but you can see visually over time how your system behave, and you can use it to validate that your model is actually depict reality. And you can use it after validation to see how different changes in the model actually going to improve, or on the other side make stuff much more worse in the system, which gives you indication how different changes actually will impact the reality. So those are flows and stock. The third one are slightly different. They are agent-based modeling. We compare them into muscular because they are actually defining how element in the system impacting one each other. So agent-based modeling are dealing with more how certain, they call it agent, which could be person or groups or technology, any element in the system has the ability to impact the system, and agent-based modeling understand how those elements in the system or agent are going to impact A, any type of flows or any type of stock, and B, how they're going to impact each other. When you are model those, it looks something like that. This is not too complex and not too simple one. What's important to understand is that it's very hard to understand for a model something about the behavior. What the model is doing is preparing the background, and once you run the model and visually, you start to get an understanding how people or groups or technology actually impact one each other and how they impact the bottom line or any type of stock that you define in the system. So this is how this diagram looks like. It started with an agent, and the dotted line is actually an agent that represents a salesperson. An agent can have, first of all, states, and those states can be changed. So we have 4 states here. Every state represents different personality in this scenario. The black line is transition, which means that it will govern or define when red is changing into yellow. Then we have actions, and you can see it here in the middle. In action, you can put logic that will govern when those states will change. It can set up data in stocks. It can set up data in variables, or it can take data from variables and do something with the data. what action can do as well is move agents on a canvas. So when you're running this model, you can see agents in 3 different ways. You can see them in grid, and every cell in the grid will represent an agent. And once you change the state, you see the grid change color. Or you can move them, you can plot them randomly and move them by the rules that you defined in the action. Or you can move them and connect them, or you can do everything all together. So moves are very flexible. And agent-based modeling is very flexible model because this logic that you can define here and the fact that you can play with data as well when you're defining a population, which is the number of type of agents that you want to create, then you can run the system and see something like that. So here it will start with random agents. Every circle, every dot is an agent. And as you can see, there are some rules that cause the red to be repelled from the green with some different attractions within. And these particular groups that the configuration that create those particular groups actually can be turned into values that shows what is the bottom line efficiency of the company. And as you can see here, you can play with different percentage and see how different personality, different combination of personalities in this particular scenario going to impact your business. So this is agent-based modeling. I hope that you managed to get a high-level understanding of 3 of them. It's really hard to do it in 1 hour, but in a nutshell, this is a nonlinear system or nonlinear thinking. So you can actually start from each one of those diagrams and do it in any way that you want. But if you're coming from a linear point of view, you probably want to use it in a slightly more linear way. And the best way to do it is to start from the causal loop diagram. They are giving you high-level view. It's easy for other people to consume it, so you can get a preliminary agreement or disagreement, whatever your basic understanding of the system is right or wrong. And once you have CLD, you can start to convert them using the logic that I mentioned into stock and flows. And stock and flows will A, give you a lower level understanding, and B, will give you also visualization in terms of simulation, so you can start to see whatever you capture has some resemblance to reality. And what I'm usually doing is every flow which is meaningful, I'm trying to do for that an agent-based modeling that will help me to understand how agent in the system actually govern or change the flow or the stock. Now, sometimes you won't go that route. Sometimes you will just do agent-based modeling because you just care about impact of people on each other or impact of groups on different stocks. Sometimes you will just do stock and flow, and in real scenario, you will just do causal loop diagram, and that will be enough. But anywhere that you're going, I suggest you to do those steps for each and every model that you are creating. The first one, you have to collect data, and remember again, stay away or be aware of mental models. Collect the data that you need and not the data that you think that you need. Second one is, once you have the data, just model it. And once you model it, if you already done any model before, you'll find out that you got more information and knowledge. And this information and knowledge will cause you to go back to the previous one and augment it to depict what you find out in the current one. Once you've done this loop, then you can start to look for changes and opportunities. Sometimes it's easy to do because you can follow archetypes like in CLD, and it helps you to realize what is the problem. Sometimes you need to operate your brain, and there aren't any rules, and it takes time and experience or common sense and experience to start to see issues within systems, whether it's in the stock and flow or whether it's in the agent-based modeling. So what I want to do now is to take everything that we've done so far, this high-level understanding that I poured on you, and take 2 real-life examples and see how everything is coming together when you are dealing with a simple problem. And to do that, I have to switch. Let me maximize it. And I'll try to increase the resolution. So I hope that now you can see it. Okay, so we are going to deal with a very simple problem. It's common, you can see it everywhere. It's a problem where usually the company goes through radical change, whatever, something like right now. Then there is a need to engage a lot of externals in order to fill a gap. And that is requiring a lot of contracts to be signed, usually from IT and marketing. And what happened in organization is that the purchasing department that needs to provide these services of the contracting is struggling for some reason that we will see in a second. And that's the problem that we are trying to resolve. So when you are doing analysis or you are breaking stuff apart, what you're going to do is a flow diagram like that. This is very linear approach. A, impact B, impact C, impact D. And you will follow those lines and you will find area where the input is lower than the output. And you stuck there and you start to find what's wrong with certain department. And usually you will let the head of department go because he doesn't know what he's doing. And then the new one will let people go because they don't know what they're doing. And then audit will come and say, oh, the process is wrong, and they will change the process. But whatever you're going to do, nothing's going to help. Every time there's going to be a load, the purchasing department will struggle to fulfill all the requests that they have to do. So that's a problem. And first thing that we are going to do in system thinking, we are going to depict it in a causal diagram. So this simple causal diagram, as you can see, each and every element has 2 lines because we want to make sure that we depict the nonlinearity relationship between each one of them. Every element here is actually their efficiency. So what's going on here is that marketing will decrease the efficiency of SSMP as they are increasing the number of requests, and SSMP, due to other problems that we discuss in a second, will have negative impact on marketing, and here we have a negative loop that goes forever. Same will apply to IT, and other business unit will have the same, simply in a lower capacity, so I'm focusing on those 2. SSMP need by policy to ask HR and legal to review contracts. Legal has to review each and every contract, and HR needs to review contract where people is going to be on site. And again, SSMP will have negative impact on HR because they are increasing the work that they have to do, and they have other work to do rather than just review contract. That will create kind of an isolating behavior of HR. When they have time, they are going to do certain contract, but most of the contract they're actually going to queue here, and this queuing going to create a delay between the contract that was sent and the contract that are going to be received. Same apply to legal even in a worse pace. And this flower that we see here and the relationship that I mentioned, this is what we called starvation. What's going on is that those 2 has a growing demand, and those 2 has a slowing ability to provide services, and the guy in the middle, the middleman, is going to have problems. And this is the problem that we are trying to resolve. So first of all, you start to see from this high level diagram that the problem is actually not here. The problem is more here and here. And when you start to ask more questions, you starting to deal with something with agent-based modeling that you can see here. Looks a little bit scary, but all you need to do is to just focus on the blue ones. So what this model is doing is taking the 4 participants, purchasing, legal, HR, and IT, and the blue box, which are stocks, defining what is their mental model, what is the main thing that drive their behavior within this system. The variables are depicting how they are seeing the process from their end. And if I would run this model, I won't do it, but I can, you will see that there is a clear correlation between the risk level and the customer and project successful and the customer satisfaction. This is indicating that the concept of legal and HR, that every contract should be reviewed, is a mental model that caused by a policy that actually caused a problem. And no one says, in reality, that every contract needs to go through those 2. From a business perspective, we can find other solution. We can convince decision maker to reduce the risk averse level and to ask HR and legal to provide learning materials that will be provided to IT or marketing. Those learning materials will define minimum and maximum approved values for certain element in the contract. And once marketing or IT are reviewing the contract and the numbers are within the permitted value, they don't need to send it to HR and legal. They can let purchasing know that this contract is within the boundaries, as purchasing can do another validation if we are really risk averse. And now if they approve it, then they just doing the contract and processing it. So we can bypass those we can bypass HR and legal for certain type of contract if we feel that those contracts have lower risk or no risk. And that way we are moving the load from here to here, and efficiency of the entire system, you'll see it in a second, is going up. So what you see here, that just by even looking at that, I managed to find that the problem is not people, and the problem is not structure. The problem is a policy that someone put in place in order to resolve one problem, but it actually created another byproduct or by problem here that with a little bit of effort and understanding, we can resolve and improve significantly the performance of the system. So this is the causal diagram, and this is the stock and flow. And as we mentioned before, every element here, let me minimize it a little bit. Okay, every element here is related to an element that we saw before in the causal diagram. The different that they have values, they have logic, as you can see here, and this value and logic actually govern how in this particular, the number of contracts are flowing between vendors to IT, to purchasing, to HR and legal, and when they're ready, we have a ready to sign contract. In order to see visually how the system behaves, we took and collect the number of contracts that purchasing was asked to do, and the number of contracts in any given time that purchasing and legal and HR approved, and we divide one by another, and then we get the efficiency of purchasing. And the beauty about this model that you can simply run it. So I can run it, and I can start to see over a month how the system will behave. And you'll see that the system will plunge down to 20% efficiency. This was the number when we started to work on this particular problem. As you can see, it's around 60, even lower. So we are stopping to refine the model when we are 70%, when the result of the model are 70% reflecting the reality that we see. Let me close it and keep on explaining what we can do with models. So this is a validation that the model is working. Now we can take the model and use simulation again to see how certain changes will impact our future. So we agree to reduce risk averse, and the question is how much? How much percentage of contract I want to bypass, and how much value I'm getting by taking this risk. And I can do it in models by defining here a factor that will be a definition in percentage, how much contract going to be bypassed, HR and legal. You see I'm starting with 0. And what I can do now is simply run this simulation with 10% of the contracts are going around legal and HR, 20% and 30%. And once I have those three, I can start to look at the data and see what value I'm getting. So this is the 10%. I'm not sure that this is the 10%. Yeah. So I'm getting into 64, and this is getting into 89. And if I take the 30, it will go even higher. And as you can see, you can see visually what are the impacts. And in this particular scenario, we choose to use the 20% bypass. It improve efficiency from 20 to 64, and 20% was worth it. And this is just one example how you can use system thinking, A, to see problems that you didn't see before, and B, to validate it, and then to predict how different element, changing of different element is actually going to help or do the opposite to a certain problem. So that's the first one that I want to show you. The second one is I just want to show you how this agent-based modeling that is very hard to understand that way is actually helping you to understand in reality when you see it, give you an insight. So I'm going to run it. What you're going to see is random number, 100 agents going to plot randomly. And then following some rules that are going to repel or attract on each other, they will create groups. And those groups has an impact on the number of customers and number of capabilities that the system produce. And then we can see visually also how this configuration changes. You can see here that you have variables, so you can actually play around and do different configuration and see how different types. So each one of them is actually personality that depicts certain personality of marketers. You can play around and see how it's actually impacting your system. So let me run a simulation. First of all, you see that every step in time, the system is applying rules and groups start to emerge. You can see that the green and the yellow, the green and the blue, the green and the red are repelling, and there's some attraction between red and blue, and some attraction between yellow and green. And over time, the system changes less and less and less, and will become stable. And once it becomes stable, it randomly or rarely going to change. On the other end, as the time moves on, you can see that data is moving to some degree, and it's impacting in some way the system negatively or positively. It simply depends. But you can see visually also how those configuration actually impact the results of the system. So in a nutshell, that's all. That I hope gave you a high-level overview of the wonderful opportunities that exist in system thinking, how 3 pretty simple diagrams will help you to significantly find complex problem and resolve complex problem. The only gotcha is that you need to change a little bit you have to change your mindset. you have to think differently in terms of systems, in terms of non-linearity and non-deterministic approaches, rather than the analysis that we are getting used to resolve problem today. So that gives us time for 10 minutes for questions. So if you have any question, the only way that we can communicate is over the chat. So yes, it was Insight Maker. So I'll be happy also to hear feedback. So if you think it was too much, if you think that it was okay, if you think that it was too high level, I'll be happy to know, because I truly believe that system thinking is the most viable tool right now in the environment that we are operating right now. And I'll be happy to refine this and help other people to gain this knowledge, because the results is really, really extraordinary. Like I used it in my life and more than once, and every time it helped me to come with solution or problems that no one else thought about it. And obviously it helped me to resolve complex problems that people before me kind of struggle resolving. Okay, I'll wait like another minute, and if no one has any question, I think that we can conclude it. If you would like to give me feedbacks directly, I'll be happy to get it. If you want to give it here, it's fine. Okay, so thank you very much for your time. I hope that you enjoyed it. I spent time and effort to do it, and I hope that I managed to do good work, at least to open your appetite and learn more about system thinking and how you can leverage system thinking for your own benefit in your own organization.